Good morning, everyone. Today we're going to be talking about how to classify polynomials. So in this unit, we're going to have to classify polynomials both by their degree and by their number of terms. So some of these terms you may have heard before, some of them might be brand new to you. If we're talking about degrees, any sort of a constant, anything that's just a number, no variables, any constant term has a degree of 0. A linear term, you might recall a linear function. It would look like the example here, this 5x plus 4. So that would have a degree of 1. We can picture the exponent of the x term, the linear term here being a 1. Our next one is a quadratic. We should be very familiar with what a quadratic term looks like. So a quadratic function has a squared term in it. So note there's a linear term and a constant term here as well. That's fine. We're kind of ignoring those. We're looking at the highest degree, and that's how we're going to classify that polynomial by its degree. So our highest exponent is a 2. The 2 is considered quadratic. So we said in this polynomials unit, we are going to look at higher degrees. So that's why now we're incorporating that. If we have a 3 as our highest exponent, we're going to call that a cubic function. It's a degree 3. A quartic function will have a highest degree of 4. And a quintic function will have a highest degree of 5. So we ignore everything else. There's no adding them together, nothing like that. We're just looking at the highest degree there is. If we're looking to classify a polynomial by its number of terms, then if it's just one term, so that's constant example here, an example of just one term, we'll call that a monomial. 2 terms will be considered a binomial. So our example here for linear is a binomial. For 3 terms, our example is the quadratic. It's got 3 terms, a quadratic term, a linear term, a constant term. There's 3 terms there. And then anything higher than 3 terms, we're just going to call it a polynomial. The prefix of poly just means many. So anything greater than 3 terms, we're just going to generically call it a polynomial. So let's take a look at the examples on the next page. So here we're going to look to see to classify each one of these expressions by its degree and its number of terms. So the highest degree here, if I'm looking through, I see a 7 as my highest degree. So a 7, if we look back, right, we don't have any special names after 5. So we're just going to call it by the number that we see. So here our degree was a 7. So this is just going to be a 7th degree polynomial. If we're looking at the number of terms, terms are separated by plus and minus signs. So here is 1 term, here is 2 terms. If we go back to the prior slide to remind ourselves, 2 terms is a binomial. So this here is an example of a 7th degree binomial. If you want to pause the video now and try to see if you can answer the rest of these, go ahead, and then you can hit play again when you're ready to check your answers. For our next example here, our highest degree is a 4. So 4, if we turn back, is going to be quartic. So our degree is quartic. And number of terms, we're looking at 1 terms, 2 terms, 3 terms. So 3 terms is going to be called a trinomial. Degree for the next one is a degree 2, so that's a quadratic. And we're looking for number of terms. So we have 1 term, 2 terms. So this again is going to be an example of a binomial. For our degree here, highest degree I see is a 3. So this is going to be 3rd degree. Remember, we're calling that a cubic. And there's nothing being separated by pluses or minus signs here. So even though we have 3 variables, it doesn't matter. There's no pluses or minuses. So we actually only have 1 term here. So we can call this a monomial. All right. From here, we also need to be able to complete some of our minor operations. So adding, subtracting, and multiplying is what we're working on first. If you recall from our lesson the other day, we'll be dealing with division separately. So standard form of a polynomial first is has to be in descending exponential order. Doesn't that sound so fancy? So let's put it in here, descending exponential order. All this means is that all of our exponents have to be in order from highest to lowest. All right, so as we go to combine our like terms here, which is really all that we're doing, let's look at our highest degree. I see a quadratic term and a quadratic term, so I'm going to add those together. So 1x squared minus 6x squared is negative 5x squared. My next term will be my linear term. So 3x plus negative x is actually just going to cancel itself out. So I can't write anything down. And actually, same idea, if I look forward to my constant terms, negative 6 and positive 6 are also going to cancel each other out. So here, if I added these two polynomials together, I'm going to get negative 5x squared. So my answer is actually just a quadratic monomial. So let's go down and take a look at the next one. Again, if you want to pause the video at any point, try them on yourself, just go right ahead. And then you can always review so you know what your answers are. Here, if I combine my like terms, I'm going to have 11m. For my k terms, I have 3k plus a negative 1k. Remember, we could put the little 1 there if you want to, is plus 2k. And then it looks like I only have one constant term, so that's easy to combine with itself. Okay. If we're going to talk about descending exponential order 2, the variable should technically be in alphabetical order as well. So final answer, 2k plus 11m. They have the same exponent of 1, but k comes before m in the alphabet, and then plus 9. So final answer. For subtraction, we talked about subtraction when we did our quadratics unit. It is the same idea. We just need to remember that we need to distribute the negative term to everything inside the second parenthesis. So I'm going to change my subtraction sign here to a positive. When I do that, I'm changing every single term after it. All right. Now that I have an addition sign, it's the same as what we had done up above. So again, I'm just going to combine my like terms. So 2x squared. Now I have a positive 3x squared to combine it with. So 5x squared. Next is negative 5x plus a 4x. So that's negative 1x. You could put the 1 there if you need to, but it's not necessary. Last one, positive 8 and a negative 1 is going to give us positive 7. So here our example is going to be a quadratic trinomial. So quadratic because the degree is 2, trinomial because we have 3 terms. So let's do it again. I'm going to change my subtraction sign to an addition sign, and when I do that, change every sign after it. Let's combine some like terms. So 7x cubed, 4x cubed makes 11x cubed. Negative 2x squared plus x squared is negative 1x squared. And last one's for constants. I have positive 7 and negative 6, which will leave me with a positive 1. So here I have a cubic trinomial. So it's adding and subtracting. Not too bad. Let's go on to multiplying. Here I gave you 2 examples, and there's definitely more of them, but here's at least 2 to start with. The first one's an example of multiplying a monomial, one term is a 2p, by binomial, 2 terms that are in the parenthesis. So we've seen this before. We did this back in Algebra 1. It's just multiplying. We're distributing into the parenthesis. So 2p times 5p squared is 10p cubed. That's why we went over exponent rules the other day. Whenever we're multiplying like bases, we're going to keep that base of p, and we're going to add our exponents together. There's a little invisible 1 here. 1 plus 2 is where the 3 comes from. Now we also need to distribute our 2p to the 7. So 2p times 7 is 14p. And that's our final answer. Next one, we've done this a million times now, it seems like, right? We FOIL. So it's the same concept. We're multiplying a binomial by a binomial. So we're going to distribute both terms in the first parenthesis to both terms in the second parenthesis. So x times x is x squared. X times negative 6 is negative 6x. Let's see, next one is now 5. The 5 has to get distributed. So 5 times x, 5x. Notice that I'm putting all my linear terms underneath each other. It makes it easier for me to combine like terms in the end. I'm not searching down some long string of numbers to find my like terms. I'm just going to stick them right underneath each other. Last one, I need to multiply the 5 also by negative 6. So that's going to give me negative 30. From here, I'm just adding all my like terms together. So x squared minus x minus 30. So again, we've seen this a bunch of times. This is an example now of a quadratic trinomial. So thank you so much for watching our little video today. You do have your homework assignment that's up on Classroom. So go ahead and work on that. Any questions, let me know.